7th grade lesson 11.1 is comparing data displayed in dot plots. So if you're given a dot plot, you might want to look at it to kind of describe or be able to describe the information that you've been provided and use it to compare information from one place to another. So this gives you the vocabulary and the pieces that you can put in place to describe it effectively. So there's 3 key words to look at. The first way you can describe it is by its shape. Is this an evenly distributed amount of data in that dot plot where the range is kind of evenly distributed throughout? Or is most of the data off to one side where you have a few outliers over here, but mostly it's all off to one side of the whole data set? So shape is one way you can describe it. Evenly distributed, off to one side, good ways to describe it when you look at it. The next word for how to describe is center. So we have shape, how it's distributed, the center of the data. So if we have a set of numbers here, let's say we had a set of numbers, and these were our set of numbers over here. Well, let's ignore this for now. Set of numbers here. We would find the median. Remember, the median is if all the numbers are ordered from least to greatest, what's the very middle number? What's the very middle value, or the center? So you would kind of cross off 1, 1, 1, 1 all the way across till you got to the middle number, and let's say that was 5 here. 1, 2, 3, 4, 5. So you would say, well, 5, it's the center, is the middle number. So it's the median. There's a vocabulary word you recognize. So what's the center of your data? So that would be another way to describe it. And a third way to describe it would be by its spread. And what they mean by spread is range. I don't know if you recall that vocabulary word, or maybe you've forgotten what it was, so I'll dust off those cobwebs. The range is the difference between the highest value and the lowest value. So you would subtract. You would take the highest value, subtract the lowest value from it. That's the range. That's what they mean by spread. Like, what is the spread of the data? What values is it in between? So you could describe the shape, the center, and the spread of the data. And those are the 3 ways in which you can describe a dot plot or compare them. So let's look at a couple of examples so we can see what that means. So here we have where people once used body parts for measurements. For example, an inch was the width of a man's thumb. In the 12th century, King Henry I of England stated that a yard was the distance from his nose to his outstretched arm's thumb. The dot plot shows the different lengths in inches of the yards for students in a 7th grade class. So a whole 7th grade class measured from their nose to their arm. You can understand doing a piece of measurement, official measurement by somebody's body parts would change varying depending on the people. We're all different sizes, right? So it probably wasn't a good measure. Yet we did it. The foot, right? 12 inches is a foot. We still use them. I don't know whose foot we measured, but we did measure somebody's apparently at one point and went with it. My feet aren't that big. So they measured all of the 7th graders nose to thumb. And these were the lengths that they got in inches. 28 inches for one student, 29 inches for 2 students. One person had 30 inches. One was 30 and a half, or 2 were 30 and a half, 3 were 31, and so on and so on and so on. Dot plot was done. They want us to describe the shape of the dot plot. Are the dots evenly distributed, or are they grouped to one side? They're pretty evenly distributed across there. We don't have like this, thing over here with this mountain going on. So I would say that they're evenly distributed. And then we're going to look at the center of the data. That's the median. So I counted all of these dots up. There are 21 of them. So I would want 10 on one side, 10 on the other. And then the one in the middle would be the center. So I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one right here would be the center. So the center of the data is 31 and a half inches. 31 and a half inches is the center, or the median, right? And then finally, the spread of the data. What's the range of it? What does it go between? Well, it's between 28 and 35. All the data lies between 28 and 35, with most of it happening between 29 and 34. So you could explain it that way. So there I've put the lengths are between 28 and 35, with most of it between 29 and 34 is what I'm looking at when I look at that picture. And then just as brushing off of cobwebs, they ask us to calculate the mean, the average, the median, the middle number, which by the way was our center, and the range where we would take this number and subtract that number from it. So let's go ahead and do that. The mean, to find the average again, is that we will take each of these numbers, 28, 29, 29, 30, 31.5, 31.5, 31, I'm sorry, 30.5, 30.5, 31, 31, 31. All of these numbers, I'm going to add them all together and then divide by 21 because that's how many data points there are. That's going to give me the mean or the average. So I'll do that. And feel free to use a calculator on that. I did. I added each of these data points up. 28, 29, 29, 30, 31.5, I'm sorry, 30.5, 30.5, 31, 31, 31, blah, 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 all the way up. And then I divided by 21 and I got 31.6 inches. So the average length is 31.6 right in here, which seems to be kind of similar to the middle. The median, which is the center we already found, was 31.5. So median is 31.5, pretty close to the mean. Generally, they tend to be, but not always. They both are ways of getting kind of an idea for the numbers, for the values that are normal for that data set. And then the spread is the range. They want us to find the range. So we're going to take the highest value of 35, subtract from it the lowest value of 28 to get the range, and it is 7. So quick refresher on mean, median, and mode. Mean is the average. Add them all up and divide by the number that are the amounts of pieces of data that are there. The median is that center number of the data set when it's in order from least to greatest, and the range is the smallest value taken away from the largest value to find out where all those numbers are in between. How many numbers does that data set spread across would be the range. Okay, so now that we know how to describe the dot plot with the shape, the center, and the spread, let's go ahead and look at how you compare one set of data to another. So we have this dot plot that shows the heights of 15 high school basketball players and the heights of 15 high school softball players. You've got the softball players and the basketball players, and you can probably guess that the basketball players are probably taller on average, but we'll see. So they're visually comparing the shapes of the dot plots. The softball, all the data is 5'6" or less. That's about as tall as I am, 5'6" or less. And for basketball, most of the data is 5'8" or greater. Most of the people are 5'8" or greater. The softball players are a little more evenly distributed for the most part, where the basketball players are kind of more off to one side. There's more that are up in the taller range as opposed to the shorter range. As a group, the softball players are shorter than the basketball players, 5'6" and below, where these guys are majority of them 5'8" and higher, or taller, I should say. So these are just ways that you can compare them. They want us to visually compare the centers of the dot plots. For the softball players, if you went to find the median and you crossed off back and forth until you got to the center, you would end up with a center right here with the data centered around 5'4". So you have the center of all the data is 5'4", where with the basketball players, the center of the data is in the 5'8" area. So that means that the most common height for the softball players is 5'4", and for the basketball players, taller at 5'8", as would be expected. Then they want us to visually compare the spreads of the dot plots, like the range of values it goes between. The spread of the softball players from 4'11" to 5'6" is the range that those players fall in. And for basketball players, they have this 5'2" guy or girl, and then up to 6 foot. So there's a greater spread in heights for the basketball players. There's a bigger range. That is like a 10-inch range, 5'10", 5'11". So 5'12" is 6 foot. So 5'2" to 5'12", which is also known as 6 foot. There's about a 10-inch range here. Where here they have 6 inches plus that one more 7-inch range. All right, then they want us to visually compare the dot plots of heights of the field hockey players to the dot plots for softball and basketball. So here is, let's have a look at our field hockey players' heights. So we can look at the values here. Let's look at the shape first. It's fairly evenly spread. It doesn't seem to be off to one side or the other, kind of like the softball players, evenly spread, and the values are similar to that of the softball players too. So I put down there that it's evenly distributed with values similar to softball. Let's visually compare the centers of the dot plot. Well, we know the center of the plot for softball was 5'4", and so the center here, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data. Divide that by 2, you're getting 7. And then, so 7 on one side, 7 on the other. The one right in the middle will be my center. So 1, 2, 3, 4, 5, 6, 7. And so this one, 5'2" is the center. So softball was 5'4". Field hockey was 5'2". Basketball center was 5'8". So the field hockey players, the center is a little shorter. So the center data shows field hockey players are a little bit shorter than the school's softball and basketball players. So I put down the center data shows field hockey players are shorter for the most part. And then finally the spread, again, that's the range. We have 4'11" being the shortest and 5'6" being the tallest. That's actually exactly the same as the softball players. So it has the same, there's the same range as the softball team. So that demonstrated how you can compare dot plots visually, but you can also compare them numerically as well. And that you're kind of looking at that mean, median, and range sort of thing going on. Numerically compare the dot plots of the number of hours a class of students exercise each week to the number of hours the students play video games each week. So they exercise this many as the data that was collected, and they play video games this many, the data that was collected. Compare the shapes of the dot plots. They almost appear opposite. They do. The dot plot shows that most students exercise less than 4 hours, but most play video games more than 6 hours each week. Compare the centers of the dot plot by finding the medians. The median of number of hours that students exercise is 2.5, right in here. And that's 6.5 hours less than the median of 9 hours, right in here, that students play video games. Compare the spreads of the dot plots by calculating the ranges. This would be 12 minus 0, which would be 12. And this would be 14 minus 0, which would be 14. So the dot plot shows the ranges to be similar to one another. The range for the amount of time that students exercise is 12 hours. The range for the amount of time that students play video games is 14 hours. So now on this bottom part, they just want us to calculate the median and the range of the data in this dot plot, their internet usage, and compare the results to the dot plot for exercise in example 2, this one right here. So we'll find they want us to find the median. Remember, that is the middle of this data set. So there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data. So right in the middle is 1, 2, 3, 4, 5, 6, 7. So it would be 6. One of those 6 would be the median. That's the center. How does that compare to the exercise one? They had the median number of hours that students exercise was 2.5 hours. So this is more. You could write this. That's the median of internet usage is more than the median of the exercise. And then the range is from 11 to 1 or 1 to 11. So 11 subtract 1 is 10. So range is 10. And the range for exercise was 12 hours. So the range of time on internet usage is less than the range for exercise time. Look at these 2 kids up here really exercise a lot. So, and this kid over here spends a lot of time on the internet. So anyway, that's how you compare those numerically. You look at their median, compare those to each other, look at their range, the spread that it goes across, and compare those to each other. So really that's all this lesson is about. It's just kind of identifying what these dots mean and explaining it using the verbiage of shape. How is it evenly distributed, center, what's the median, and what's the spread, the range. So that's pretty much it. I think you should do just fine.